Through this module of simple Keynesian model, we shall be able to understand the determination of equilibrium income and output in the two-sector economy, know how the process through which this equilibrium is reached, learn the concept of multiplier in two-sector economy. Once we are through with the two-sector economy, we shall move on to understand the determination of equilibrium and output in a four-sector economy, know the process of reaching the equilibrium level, and finally learn the concept of multiplier in four-sector economy.
Keynesian economics brought about a revolution in the field of macroeconomics by challenging the classical school of thought. The classical school believed that the supply side of any economy is more important and that the production process is most important feature of macroeconomy. This simply asserts the fact that supply creates its own demand. That is, production gives rise to consumption. Keynesian economists, however, believed that demand is more important than the supply and that the demand creates its own supply. In the simple Keynesian model, equilibrium occurs when the aggregate demand is equal to the aggregate supply. In other words, it occurs when the total expenditure is equal to total income. In this model, we will discuss about the Keynesian model of national income determination, starting with the basic two-sector economy model and moving on to complex four-sector economy model. The Keynesian model of macroeconomics with two sectors, that is households and firms, is often termed as basic or private sector model. The reason behind this name is that it captures the basic features of Keynesian model as well as it only includes two private sectors, households and firms. The household sector includes the entire population of the economy, that is, everyone in the economy who consumes goods and services. This sector is responsible for consumption expenditure. On the other hand, the business sector consists of private firms which results in production of goods and services and is responsible for the investment expenditure in the economy. These sectors help in making a critical distinction between different types of expenditures, namely induced expenditures, which are dependent on the level of national income, and autonomous expenditures, which are not dependent on the level of national income. You will come across both these terms throughout this module. Both consumption and investment expenditures have autonomous and induced components, but the two-sector Keynesian model assumes that investment expenditure is autonomous in nature, while consumption expenditure has both autonomous and induced components. By including the government sector and the foreign sector, we create the four-sector economy under Keynesian economics. It is also known as open economy, as the economy is open to transaction with the rest of the world. The government sector affects the economy through various economic activities like government expenditures for goods and services, taxation policies, transfer payments, etc. Inclusion of foreign sector affects the level of aggregate demand through import and export of goods and services. Now, we have got a brief outline of national income determination in various economic models. Let us study them in detail.
Through this module, we attempt to explain the determination of equilibrium income and output in several models based on different assumptions in the goods market. The simplest model assumes a two-sector economy of households and firms, without government and external sector. Gradually, we introduce complexity and get closer to reality by bringing in government and external sector. Let us start with a simple two-sector economy without government and foreign sector. In such an economy, households are the consumers and firms the producers. Investment is assumed autonomous for simplicity. We know that aggregate demand is the sum of consumption and investment expenditures. This can be written as AD is equal to C plus I. Since there is no government, there will be no taxes, and Y is the same as the disposable income of the consumers. Thus, the consumption function can be expressed as C is equal to A plus BY. We know that equilibrium condition in the goods market is written as Y is equal to AD. Moving on, we substitute the value of C, that is consumption, in the demand function and the value of aggregate demand in the goods market equilibrium equation. We arrive at the following equation. Y is equal to A plus BY plus I, which can be further written as Y minus BY is equal to A plus I. Then Y brackets 1 minus B brackets closed is equal to A plus I. Thus, the equilibrium output level is given by YE is equal to 1 upon 1 minus B multiplied by A plus I. This equilibrium income determination in a simple two-sector economy can be explained graphically too. The upper panel consists of the consumption curve and the demand curve AD. The horizontal axis measures aggregate output while the vertical axis measures the components of aggregate demand. The consumption function is given by C is equal to A plus BY. The aggregate demand curve is the sum of C and I. Since investment is assumed to be autonomous, AD curve has the same slope as that of the consumption curve, and the vertical gap between C and AD is investment I at each level of income. A 45-degree line has the property that any point on it, the horizontal and vertical coordinates. This analysis indicates that there is a unique equilibrium at which aggregate demand, that is C plus I, of the economy is equal to aggregate production or supply Y. Now, the lower panel of the diagram consists of the savings curve and investment curve I. It can be seen that the equilibrium level of income, that is E in the upper panel, coincides with the equilibrium point determined by the interaction of S and I in the lower panel. Essentially, both these equilibrium conditions. Now, let us understand this equilibrium determination with the help of a simple example. Suppose the consumption function is given by C is equal to 12.5 plus 0.75y. The investment is given by I is equal to 120. AD, which is the sum of consumption and investment, is 12.5 plus 0.75y plus 120, which is equal to 132.5 plus 0.75y. We know that for equilibrium, y is equal to AD. That is, y is equal to 132.5 plus 0.75y. This gives us 0.25y is equal to 132.5, and the equilibrium y is 530. Also, y is equal to C plus I and S is equal to I at the equilibrium. Therefore, we can show that S is equal to y minus C, that is, S is equal to y minus 12.5 minus 0.75y, which is equal to 0.25y minus 12.5. Substituting the value of y, that is 530, in this equation, we get S is equal to 0.25 multiplied by 530 minus 12.5. which is equal to 120 and which is finally equal to the investment. Hence, at this output level, savings is equal to investment. Only at the equilibrium level of income, that is 530 in the example, will unintended inventory change be zero. At a lower income level, where Y is less than AD, demand exceeds production and there will be depletion of existing stock. For example, if Y is equal to 500, AD can be computed as C plus I, where C is equal to 12.5 plus 0.75 multiplied by 500 gives us 12.5 plus 375, which is equal to 387.5. So, AD is equal to 387.5, which is the consumption, plus 120, which is the investment, and AD is equal to 507.5. AS is the level of production, that is 500. In this case, AS is less than AD by 7.5 and there is unplanned depletion of inventory stock as 7.5 units are taken out of the existing inventory stock to meet the gap between demand and supply. On the other hand, at a higher income level where Y is greater than AD, there would be addition to existing stock of inventory. For example, if Y is equal to 550, AD can be computed as C plus I. C is equal to 12.5 plus 0.75 multiplied by 550 is equal to 12.5 plus 412.5, which is equal to 425. So AD is equal to 425, that is consumption, plus 120, that is investment, and is equal to 545. AS is the level of production, that is 550. In this case, AS is greater than AD and there is unplanned addition to inventory stock by 5 units.
Multiplier can be defined as a factor which measures a change in endogenous variables due to changes in exogenous variables. Keynesian Economics calculates multipliers which measures the change in aggregate demand or income due to changes in an exogenous spending. It quantifies the changes in national income because of investments, autonomous consumption, or capital deposits into the economy. The basic premise of multiplier theory is that any injection into the economy through investments, government spending, or anything like that will have a proportional effect on the income level. That is, the increased spending will have a carry-through effect. In general, multiplier is calculated as 1 divided 1 minus marginal propensity to consume. Therefore, higher the marginal propensity to consume, higher will be the multiplier. The concept of multiplier not only has theoretical significance but also great practical importance. Let us study this in detail now.
Now, let us understand how equilibrium gets affected if there is a change in any component of aggregate demand. We will see that equilibrium income changes by a multiple of initial change in any component. This concept is referred to as the multiplier. Continuing with the same example of income determination, where C is equal to 12.5 plus 0.75y, I is equal to 120 and equilibrium income is 530. Now, suppose investment increases to 125. The new equilibrium becomes y is equal to 12.5 plus 0.75y plus 125. This results in equilibrium output equal to 550. Therefore, when investment increases by 5 from 120 to 125, income increases by 20, that is from 530 to 550. There is an increase in income that is a multiple of increase in investment. In this example, the multiplier is 4. The multiplier denoted by K works not only for an increase in autonomous investment but for any component of autonomous demand. Thus, the multiplier may be defined as the increase in income resulting from an increase in any autonomous component of aggregate demand. It may be computed as K is equal to 1 upon 1 minus B, where B is the marginal propensity to consume, that is MPC. It can also be written as 1 divided by MPS, where MPS is the marginal propensity to save. Therefore, for the discussed example, K is equal to 1 upon 1 minus 0.75, which is equal to 1 upon 0.25, which is equal to 4. There are 2 points to remember in case of a multiplier. First, an increase in B or MPC increases the value of the multiplier. This is so because a higher B implies a higher level of additional consumption in the economy from an increase in income. In contrast, a higher MPS, that is 1 minus B, will lower the income generating power of an increase in autonomous investment or consumption. Second, the multiplier works both ways. While an increase in autonomous component of demand results in multiple increases in income, a decrease in autonomous component of demand will also result in a multiple decrease in income. Now, we know the definition of multiplier. Let us understand the logic behind it. We will see what sets off the process so that there is a multiple increase in income. In our numerical example, marginal propensity to consume is 0.75. If the autonomous demand increases by 100, then there is an increase in income by 100 as output increases by the same amount to meet this extra demand. However, this is only the first round direct impact of increase in autonomous demand. Due to this increase in income of 100, consumption increases by 0.75 multiplied by 100, which is 75. Output, and hence income, rises by 75 to meet this demand. In the next round, the increase in income of 75 results in increase in consumption of 56.25, which is 0.75 multiplied by 75. Output and income will go up by this amount in response to this rise in demand. This process will continue and it will look like a geometric progression. Change in y is equal to 100 multiplied by 1 plus 100 multiplied by 0.75 plus 100 multiplied by 0.75 square plus 100 multiplied by 0.75 cube and so on. The initial increase in autonomous demand of 100 will result in increase in income of 400, giving a multiplier of 4. Next topic that we will discuss is an interesting result known as the paradox of thrift. It shows the importance of demand in Keynesian economics. Suppose that at some point the citizens of an economy decide to become thriftier and begin to save a greater amount at each level of income. Planned savings increase at every level of income and planned consumption expenditure falls. This is equivalent to a decline in autonomous C. With the value of investment remaining unchanged, the result will be a decline in the value of equilibrium income. Since we must have S is equal to I in equilibrium and I has not changed, saving will remain at the old level despite the rise in the propensity to save. This is the paradox. What is happening is that the attempt to save more is depressing output by lowering consumption demand. Ultimately, due to this fall in Y, saving continues to be equal to the unchanged level of investment. Let us understand this with an example. Start with the consumption function C is equal to 1 2.5 plus 0.75y. Now, the autonomous consumption changes from 1 2.5 to 1 0.5. The new consumption function becomes C is equal to 1 0.5 plus 0.75y. Investment is 120. The new equilibrium will be at point where y is equal to C plus I. That is, y is equal to 1 0.5 plus 0.75y plus 120. By solving this equation, we get y is equal to 522. At the new equilibrium income of 522, savings is equal to S is equal to y minus C is equal to y minus 10.5 minus 0.75y. Substituting the value of y as 522, we get S is equal to 120. Thus, S has remained unchanged at 120, which is equal to I in the new equilibrium. We have now studied the equilibrium determination in the simple two-sector economy without government or foreign trade. The process is similar when we make the model more complex by expanding the number of sectors. Now, we introduce government and the external sector. Let us start with the government sector. The government affects aggregate demand by purchasing goods and services G, levying taxes T, and providing transfer payments to households TR, such as unemployment allowance, subsidies, etc. Taxes are assumed to be proportional to income and government expenditure and transfer payments are still assumed to be constant. Introduction of foreign trade would imply that we need to incorporate exports and imports or net exports in the model. The demand for imports will increase as income increases. However, exports are dependent on foreign income and not domestic income and are considered as autonomous in this model. In this model, it is assumed that M is equal to M naught plus My, where M is greater than 0. M naught is the autonomous demand for imports and the small m is the marginal propensity to import, a concept which is similar to the marginal propensity to consume or save. It captures the extent of increase in imports due to a unit increase in income. Now, according to the four-sector model, aggregate demand is the sum of consumption expenditure, investment expenditure, government purchases, and net exports. That is, AD is equal to C plus I plus G plus NX. For equilibrium, supply should be equal to demand expressed as Y is equal to AD. Therefore, substituting the four-sector model aggregate demand equation in this condition, we get Y is equal to AD is equal to C plus I plus G plus NX. For simplicity, investment, government purchases, and exports are assumed to be autonomous. Consumption has both autonomous and induced parts given by C is equal to A plus B y D. The disposable income YD is income minus direct tax capital T is equal to small t y, where small t is the rate of proportional taxation and is between 0 and 1. Therefore, disposable income can be written as YD is equal to capital Y minus small t capital Y plus TR. Substituting YD in the consumption function, we get C is equal to A plus BY minus BTY plus BTR. The equilibrium condition is Y is equal to C plus I plus G plus net exports. Substituting the value of C and Nx, we get Y is equal to A plus By minus Bty plus Btr plus I plus G plus X minus M naught minus My. Now taking all the y values on the left hand side and solving this equation for y, we get the equilibrium income as YE is equal to 1 upon 1 minus B plus BT plus small m brackets A plus BTR plus I plus G plus X minus M naught bracket closed. This is the equilibrium income in the four-sector economy. Now, let us study the multiplier in case of a four-sector model. The autonomous values in the case of a four-sector economy are the autonomous values of consumption, investment, government spending, and net export. Thus, the multiplier is given by the equation K is equal to 1 upon 1 minus B plus BT plus M. The multiplier is now smaller than that in the simple two-sector economy. It should be noted that both taxes and imports are leakages from income and expenditure flows. Through this module, we have learnt that in a two-sector economy, only households and firms are considered for calculating the equilibrium income, while in the four-sector economy, government and external sector are also included. Government activities of purchasing goods and services levying taxes and providing transfer payments to households such as unemployment allowance, subsidies, etc. are considered part of the fiscal policy of the government. High marginal propensity to import and high tax rate depress income because imports and taxes are leakages out of the expenditure on domestic production. The process by which an increase in autonomous expenditure results in a multiplicative increase in income or output is referred to as the multiplier. In a simple two-sector economy, the multiplier denoted by K is K is equal to 1 upon 1 minus B, whereas the multiplier in the four-sector economy is K is equal to 1 upon 1 minus B plus BT plus M. An attempt to save more will be frustrating because income will fall with the decline in consumption demand. This is called the paradox of thrift.
This module helped us in understanding the national income determination in Keynesian economics. Keynesian economics considers aggregate demand to be of critical importance, and the equilibrium is maintained at the level where aggregate demand is equal to aggregate supply. We learned about the equilibrium national income in two-sector model with households and business sector, and four-sector models which has government and external sector along with households and firms. We also studied about the multiplier effect in both two-sector and four-sector models and how multiplier effect can operate continuously only if there is continuous and autonomous changes in the expenditure in the economy. Two models were considered in this module to understand the process of income determination in a Keynesian model. Several such models with varying degree of complexity may be designed, but the basic point of Keynesian theory remains the same. These models emphasize the importance of aggregate demand in determining the equilibrium. A change in any one of the components of aggregate demand, such as government expenditure or investment or net export, will have a multiplicative impact on income due to the operation of multiplier process. However, it needs to be noted that the models considered in this module were confined to the goods market. To completely explain the Keynesian theory, we need to incorporate the asset market as well.